Thank you. Good afternoon. So I would like to thank Marco, who got us thinking about scuba diving domain in his talk earlier on this afternoon. Except he went off and talked about the wrong thing, because in one of his early slides, he mentioned something that left me thinking, yeah, but what is a wetsuit size? He did not answer this question. He suggested that there might be something interesting going on there. He just mentioned you have small, medium, and large, but what I don't know is, are these ISO wetsuit size codes ISO standard? Or is this a terrible example of Western cultural imperialism, and these are the wrong sizes that do not work elsewhere? Problematic. So while modeling often gets us to think about the attributes and the relationships of entities and the large-scale things like aggregates, in this talk I'd like to focus on individual value objects and individual values and how do we model those. Because it's not enough to say that a value is text or a number or a date. You need to model, I think, these more specifically. So what do we mean by a customer name or an address or a gender, a bank account number, or even a wetsuit size? I'm going to start with names, because names are interesting and names always come up in modeling. And what I'm looking for is opportunity to model these universal values in a safe, repeatable way. Are there standards for these things? So I'm going to start with an example of Annemiek van Vleuten, who's a successful Dutch cyclist, won many prizes, many races. Now, Annemiek has a given name and a last name, if you'd like to describe it like this. And the last name has, yeah, this is awkward, a tussenvoegsel. Now, that's a Dutch word. And so, if you work in this country, especially if you're a native English speaker, somebody's going to ask you, how do you translate this word for that little word in the last name? This is what we in domain modeling call a trick question. The correct answer is that you should not try to decompose personal names, people's names, into their parts. It does not work. I mean, in Dutch, you can talk about these parts of a last name, but it only works in Dutch. It does not work for other countries. In fact, personal names, or their structure, if they have any at all, is country-specific. So trying to break these up, trying to sort of model these in more detail, actually is a bad idea, does not work. So it turns out that names are country-specific. So for example, this leads to issues like the fact that in a Dutch list of names, you would sort by VL in this case, but in the US, you'd probably sort by VA. This inconsistency is the kind of trap within something that's just, you would have hoped, as simple as a name. If you haven't, you should have already read the famous blog post about falsehoods programmers believe about names by Patrick McKenzie. And I'd like to just highlight 4 of the entries in this list, in his list, which are the idea that you might be able to ignore these differences, that it might not matter somehow. Assuming that you can ignore country-specific differences in people's names is not inclusive. In fact, it's a special kind of non-inclusivity that we call being racist. This is not a good thing. But this is pervasive, so we need to figure out how to stop doing this. So names turn out to be a problem. I could give you lots of examples. In fact, this could take all day, but go and follow Your Name is Valid on Twitter, which shows daily examples of people's software getting this wrong. And getting this wrong is something that people take personally because it's their name. So don't tell somebody that their name is invalid, and just don't tell a person that they are, as a person, not valid. Names are a minefield. There are guidelines. There are guidelines from the World Wide Web Consortium, which essentially boil down to allow everything. Don't think that you can validate a name and say that it's not a name. And certainly don't try to parse or split them up. What you should do instead is have different variants of people's names for different purposes. So if you have a full name, you maybe want a nickname to greet people in emails. So this turns out to be something that I'm going to come back to on many of these slides, that while something like people's names are quite universal as values, how you need to model them turns out to be domain-specific. Sometimes it's more straightforward. So if you're dealing with identifying spoken languages, then there are ISO standards for this, and this is great. You have 2-letter codes for languages. This is very straightforward. You have them for countries as well. These are in uppercase. Don't mix the two up. That would be confusing. And also currencies. In case you didn't notice, the 3-letter currency codes start with a 2-letter country code, followed by something else for the currency, although not all of these currencies are still in use. So some of these codes are very standard and easy to use with, but you don't show these codes in user interfaces. That would be a bit nerdy. We get used to them as programmers, maybe. But in practice, in your user interface, you may need to do this. You may need to translate those kinds of names or standardize things like months of the year or days of the week into different languages. Now, the months of the year are a fairly standard list of values. And the good news is somebody's done this for you. So personal names, that was mostly bad news. Months of the year, units of measurement, writing systems, alphabets. These are all translated by the Unicode Common Locale Data Repository project, which despite its very retro 90s website design, they've got some excellent data for localized names. So you can use this to look up and use standardized translations in many languages. And this is data that's available online in XML or JSON format. So for some sets of data, these kinds of values, you're in a good position. There's a standard list you can use. What's a common theme with modeled values is that they are frequently enumerated types. There's a fixed, finite list of possible values. Ideally, somebody else has documented that list, which is why I'm looking for the international standards here. Let's look at some more examples in addresses, because addresses often are, well, used next to names if you want to send somebody a package. So addresses include the countries I mentioned earlier, but here's where it becomes problematic. So countries are not visible on the satellite photo because they're a construct. And they're not a construct that everybody has the same answer to. So while identifying an individual country, such as the Netherlands, is straightforward because you can use an ISO 2-letter code for that, a list of countries is harder. Now, by country, we probably mean a sovereign state. And these are identified by these ISO codes. And they have translated names in the Unicode database. So that's the good news. The bad news is that if you want to not just model an individual value, but you want to have a list of the possible values, then nobody agrees anymore. Or rather, there are a number of countries that are not universally recognized. There's a list of flags here, and some of them don't even get emoji flags before at the end. So that's unfortunate. It makes your life difficult. So this means that if you are modeling country as part of your model, you can use the ISO code, and that's great. But if you need the complete list, it depends who you're asking and who you need to show it to and what it's for. Now, you might think that that would be completely straightforward if you're looking at things like postal addresses, which takes us to postcodes. The map shows postcodes by country according to what kind of postcode people have. Most of the world has postcodes, but not all of it. Again, this is awkward, so even the idea of a postcode is not universal. It turns out that most countries use postcodes that are just digits, which I don't realize because I grew up in the UK, which has letters in the postcodes, and I moved to this country, which has letters in the postcodes. Turns out that's not particularly common. And most of the other countries have far more sensible postcodes that are just some sequence of 3 to 10 digits, much easier to work with. I also learned on my way down this particular rabbit hole that while it was possibly the latest member of the Universal Postal Union to get postcodes, Ireland has the best ones because they uniquely identify delivery addresses. I wish we all had that. That would make so much of our software easier to do. But that's not the way it is. These models are country specific. And so in a lot of the software we build, we're building for a global market. This is not just for one country. That would be much easier. But it's not international like that. What is international is something like an email address. So you would expect an email address, internet age, to be so much simpler. After all, there's a standard. Why would this be hard? Well, the first problem is that there's not just the standard, there's the standard that replaced the standard that replaced the standard that replaced the standard. And figuring out what is an email address from reading all of these is not an easy task. Why do you want to know? So I didn't actually mention the why. Why do we care about these modeled values? Well, often what we want to do in our software is, for example, validate a value that somebody's entered. We want to identify whether this is plausibly or actually an email address. That's complicated for email addresses. There's the request for comment, the standard, that says, is this the right format? Like, is this potentially an email address? But that's not enough, because that domain might not exist. Or it might be a domain that you don't want to allow. So you need to look at the domain as well. And just because an email address has the right format for a domain that exists, there's not necessarily actually an email address at that address. Like, the email might not get there. So to check this, you would actually have to send the email. So even at this third level, you can't validate an email address with anything less than sending an email to the address. And even then, you don't know whether it's the correct person, which is why we need these workflows for validating email addresses with click. And I used to think that was enough. I mean, it's bad enough. There were 4 levels of email address validation until I had a chat with the security team who explained that actually, in practice, you don't want to allow any valid email address, according to the RFC, because while there's some syntax which is less common but useful, such as a plus sign in the first part, there's lots of valid email addresses that, in practice, only 2 groups of people use, namely security researchers and hackers. And the very obscure subformats of email addresses are something that your development team might not have considered. There could be a security vulnerability, so now you need to consider what to allow. Anyway, so email addresses, total disaster. There's a lot you can do. You can get software help with this, but it's a complicated thing. So what I've learned from addresses is it's very real world, it's very messy, and it's worth going down the rabbit hole because you can avoid making some classic mistakes. So I didn't want to do this, and then I did, and I'm going to have to talk about gender, because you get this on forms, and this is problematic. So how problematic? Well, here's the classic example. There is more than one thing wrong with this particular form. I'm not even sure what's most obviously wrong about this, but the easiest thing to notice that's wrong about this is that there are 2 options. And it's kind of a golden rule in modeling is that there are always more than 2 options, and that applies here too. So do not model things as a Boolean type in your data storage or your transport. It's almost going to end in tears because there are more options than that. So don't do that. But actually, the more important observation for this one is that this is a type that you probably shouldn't be asking for in the first place. We have legislation about this. So occasionally, there are external forces that constrain us about how we model our domain. And the GDPR is one of those. So the GDPR in Article 5 talks about what it calls data minimization. Don't ask for things you don't need, especially when it's personal data. So personal data must be necessary, among other things. This is probably not the case for your software. It's not the case for software that I've written in the past. There is software for which you do need to ask for gender. But on the whole, we should be building unisex software. We should have unisex models. And you need to learn about the rules here. I did, until fairly recently, naively think that the legal department might just check things like this for us. That's not how it works in most companies. You can't rely on legal to do this right for you, so you need to get this right yourself as a software designer, as a modeler, and as a software developer. So learn about personal data and data minimization. Don't ask for gender when you don't need it. And if you really do need it, probably because it's a legal requirement, I don't know, maybe you're making a passport application form, then you need to find out the legal justification for asking, and you need to find out what the correct possible answers are. In many cases, it could be free text. If it's a passport application form, it's for a specific country that probably has legislation about what the possible values are. Increasingly, there are countries where there's more than 2 options. Not many, but that's a new thing. So names are problematic, addresses are a mess. Gender is something that you really shouldn't be getting wrong anymore. There's no excuse for that. What's almost certainly going to be better is numbers, because numbers are much more well-behaved. Like house numbers, which are numeric and sequential. Well, except when they're none of those things. So this is a house I lived in when I was a small child, about so tall. That's my grandmother looking out the door. And this whole street on the south coast of England by the beach has a row of houses, none of which have numbers. The first one is called the Boathouse. That was the address, the Boathouse in this particular street. But it's called a house number. And that's probably the correct name when you model this. Okay, but maybe other numbers are better, like telephone numbers, because they only have digits in, except for the punctuation. So they're not entirely numeric. The plus sign may be important. And they're not, they're numeric in the sense that they're constructed from digits, but a telephone number is not a number because the leading zeros are significant. So you can't be treating that as a number. Telephone numbers also introduce a new problem, which is the wish to store them in one representation, such as digits and plus signs only, but maybe display them in a different representation with grouping, spaces, that kind of thing. So you need to think about the two. Now, how do you group a phone number? How do you group the sections in a phone number? Country specific, of course it is. There are international telephone number standards, and they do not help at all. They say useful things like, you should really use spaces for grouping, but unless you don't want to. They certainly don't help. There are software libraries that will try and group it right if you say which country you're talking about. But in many countries, you just have to know what kind of number it is or which town the area code represents. Total nightmare. So telephone numbers are problematic. So we're not going to find any satisfaction there. But it's quite a rich topic again, and if you're working with phone numbers, you need to not make mistakes here and get it right. My recent favorite on exploring numbers was aircraft tail numbers because aircraft look nice, although we fly less these days, so we don't see those so much. Now, aircraft have registration numbers, like cars, commonly called tail numbers because they're often printed on the tail, except when they're not. This aircraft has a tail number printed on the side and underneath the wing, if you can see that. Has 2 parts. So an aircraft registration number has a country code, a dash, and then some other bit. The whole thing's unique. Horrifyingly, the country code is not an ISO 2-letter country code. I looked into this. Why is PH the code for the Netherlands? Turns out it was originally H, but that was recognized to be confusing because Hungary is also the name of a country that starts with H. So they added the P to make it less confusing. I can't explain this. Although it's my initials, so it's kind of nice. So, I see my initials on all the planes at Schiphol. That's something to do while I'm waiting, as you do. And many aircraft tail numbers in the Netherlands don't have any digits in at all. Latest government plane is registered to PH-gov. Did you know? Vanity registrations are a thing for aeroplanes as well. So what these all have in common is also shared with something like IBAN bank account numbers. There's a system, it comes from somewhere, there's a history, but there's often letters as well as numbers in there, which complicates things. IBAN share what telephone numbers have about the storage representation and then the display one with spaces in. The actual length is country specific because of course it is. It varies quite a lot in the number of digits you're going to get. But generally, this is a great improvement. It's some kind of standard, and this makes it easier to know how to deal with account numbers for people's bank accounts. And they're used in Europe and some parts of the world, just not everywhere in the world. So that's, again, a shame. Please, could more of the world use IBAN? That would make our lives easier when we're building software. So there's progress. I mean, IBAN is a great example of a standard that is useful, not yet introduced everywhere, if that will ever happen, has taken a very large number of years. So this is not easy stuff to fix, but it's very useful when it does happen. There are many other useful standard numbering sets. I guess we know about ISBNs on the backs of books. Published books have numbers, but so does published sheet music. So does published, or should I say, bottled wine. There's a wine number. And there's also kind of product codes that you get on things you buy with barcodes. Again, these are things that enable commerce especially and are useful things to use in the software. So the domain modeling lesson here is that there may be standards in your domain that you don't know about. You should definitely be using them. You should definitely know about them. So this is not the kind of domain modeling where you need to think hard or do an event storming session. This is where you need to do some research and find out what is the prior work that you can use. Because there are great advantages to other people's standards. Particularly, they have occasionally clever things like the checksums in IBAN. There's an algorithm to check whether you transpose 2 digits. It won't be a valid number anymore. But more importantly, there's other people's documentation, so you don't have to write that. And so in the end, the thing about numbers is they're usually not numeric. So here's a tip for you. When you're modeling something, if somebody calls it a number, patient number, account number, customer number, it's probably not a number, and you should certainly not try and store it in a numeric data type in your software or storage. It's usually text. So I want to wrap up by apologizing for not being able to have discovered a suitable ISO standard for all of the things we use all the time, because it turns out it's worse than that. What we need to do instead is to understand what standards are there and model these universal values according to their purpose. So these values are universal in the sense that addresses and people's names, postcodes, these exist outside your software. They're out in the world, and they're frequently global. But how you deal with them often has to be domain-specific or even application-specific. There are many things you can get wrong. And so it's up to you as software developers to figure out what are the rules, how do you get it right. Mostly, you don't have to invent this from first principles. So that is at least some good news. And as well as being specific to your domain, the idea that they're different is also an opportunity to look for fun things you can do. So don't expect to always use the same modeling approach in every bit of software you build. A dating app would be quite cool, maybe, if gender were a free text field. Thank you very much. Many of the slides link to blog posts. These are linked on my website from this URL on the slide.